Hello everyone, you're welcome to another math class. Today we'll be looking at ratio and proportion. Ratio and proportion. First we are going to look at ratio because with a good understanding of ratio we'll be able to grasp the concept of proportion. We first need to understand ratio before we go on to proportion. Okay, so what is ratio? We may have heard about this, we may have heard of this word or not, but it doesn't matter, we're going to look at it. And I'm very sure by the time we're rounding off this lesson, we'll all have a good understanding of this concept. Ratio is the relationship between two quantities or two numbers. Ratio is the relationship between two quantities or two numbers. It's like when you are comparing two things. It's like comparison, okay? Ratio helps to show the relationship that exists between two quantities or two numbers. When you compare them, it shows what relationship exists between them. Now, an example here is maybe there are 7 rulers and 5 pencils on the table. You have 7 rulers and 5 pencils. And the ratio of the ruler to the pencil in that case would be ratio 7 to 5. In the middle, when you are writing ratio, you use the symbol of colon, 2 dots in the middle, and it is read as to. In representing ratio, you use colon symbol in the middle of the two numbers that you are comparing, and it is read as 2. So 7 to 5 can also be written as this. They mean the same thing. They mean the same. Okay, so ratio means the relationship that exists between two things. For instance, you have 7 rulers and 5 pencils. If you want to express them in the ratio form, you will say that the ratio of ruler to pencil is 7, because there are 7 rulers, 7 to, see the dot, that colon, 7 to 5. That's the ratio of ruler to pencil, and it can also be written like this. This is another way. And if you are reading this, you read it like 7 to 5. Okay, so let's look at another example. Actually, in looking at ratio is quite easy. The major thing we're going to look at, that we really need to look at in ratio, is the fact that when we express ratio, as much as possible, we try to express them in the lowest terms. What does that mean? It means that whatever two numbers we are using like this to represent your ratio, you try to divide the two of them with the same number until you can divide further. Okay, we reduce the numbers to their lowest possible number by dividing them with the same number or numbers. Okay, now we have another example here with us. 32 boys, 18 girls in a school. 32 boys and 18 girls are in a school, and you are asked what is the ratio of boys to girls. You are comparing the two. You are trying to find out the relationship between the number of boys and the number of girls. So remember, when you are dealing with ratio, always take note of what is written first. And whenever you are expressing the ratio, you write the number of whichever quantity is mentioned first before you write the other. For example, boys is mentioned first here, and we have 32 boys. So it would be very wrong if you go and write the ratio is 18 to, you write girls first and then you write 32, which is for boys. No, this is wrong. Now, boys came first, so the number of boys needs to be written first. So you're going to write the ratio of boys. Now boys is 32 and girls is 18. Okay, so you make sure that the number of whatever you are measuring stays in the right position. Now your toe is represented as column. So the ratio of boys to girls in a school like this is 32 to 18, or you can also write it as 32 to 18. Okay, now there's something I need to point out to you here, and it's what I was mentioning or talking about when I finished the first example, that as much as possible you try to reduce your ratios to the lowest term. You try to reduce your ratios to the lowest term. Now what do we mean? I said it means you use a particular number or numbers if need be to divide the two numbers in your ratio until you cannot divide them further. Like the other example we had 7 and 5. Those two numbers, there is no single number that can divide the two of them, so they are in their lowest term. Now, but let's look at these two numbers that we have here, 32 and 18. What do we notice about these two numbers? They both end with even numbers. That means this number and this number are even numbers. Any number that ends in an even number is an even number. We know that. And any number that ends with an odd number is an odd number. So 2 is an even number, 8 is an even number. That means 32 and 8 and 18 are even numbers. And what does that tell us? It tells us that 2 can divide these two numbers, right? So we're going to use that same number, which is 2, to divide these two numbers until we cannot go further. Okay, so we divide them by 2. 32 divided by 2 will give us 16, and 18 divided by 2 will give us 9. Now if you look at 16, 16 is an even number, 9 is an odd number. And we know that 2 cannot divide an odd number. Now if we try to check 3 can divide 9, but it cannot divide 16. So we find out that there is no single number that can divide the two of these numbers, that is 9 and 16, without leaving a remainder. So 16 to 9, ratio 16 to 9 is the lowest term that this ratio can be expressed in. So this is how you are going to leave your answer, the ratio of 16 to 9. Okay, so if you have ratio numbers representing your ratio or numbers in your ratio that both can still be divided by a single number, you go ahead and divide them, okay, until you get an answer that you cannot divide further. So this is ratio, and I think it's quite easy. You know, it's just showing the major thing you need to know in ratio is, one, the way you represent it or the way you write it, the symbol you use, okay? The way you read it, you also need to know that is toe. This symbol stands for toe, and even the toe can be written out literally. 32 to 18, ratio 32 to 18. Okay, let me put this here. If you are reading it, you write ratio 2 to 4, ratio 3 to 6, ratio 5 to 8, you know, just like that. So, and then the other thing you need to take note of is what we looked at here now. If you have two numbers representing your ratio and you know that there is a single number that can still break them down, further divide them, go ahead. You need your ratios to be in the lowest term as much as possible. Okay, it's not as if you can't leave them without in the lowest term, but it's advisable you take them to the lowest term possible. Okay, so for every 16 boys, there are 9 girls. For every 16 boys, you have 9 girls. That's what that means. Okay, All right, so maybe we take one more example and then we'll move on to proportion. Now I'm going to show us something quickly before we move on to something else. The example we just considered now, we said there are 32 boys and then there are 18 girls. And then we wrote it out as ratio 32 to 18, right? That's how we write it in ratio. The ratio of boys to girls is 32 to 18. And remember, we divided the two numbers further and we got 16 to 9, right? We divided both numbers, that's 32 and 18, and we got 16 to 9. Now what this is saying is, for every 32 boys, we have 18 girls. And then for every 16 boys, we have 9 girls. Now looking at these two, they represent the same thing. Now let's see how they represent the same thing. Now bring out 16 for every 16 boys. Now you have 16 boys. How many girls you're bringing out? You are bringing out 9 girls. Okay? Let's say this is the first set. Now you bring out another set of boys. For every 16 boy, you bring out 9 girls. Now let's see, we have brought out 2 sets of 16 boys and 2 sets of 9 girls. What do we have? If we add our 16 plus 16, we have 12. Take 1. 1 plus 1 plus 1, 3. And 9 plus 9, 18. You see that it brings us back to where we started from. For every 32 girls, you have 8. For every 32 boys, you have 18 girls. For every 16 boys, you have 9 girls. These two ratios represent the same thing. And so they are called equivalent ratios. Equivalent ratios. Okay? I just wanted to quickly show us this way. Let's see how we build equivalent ratios. In this case, I divided. But I also want you to know that you can build equivalent ratios by multiplying the two numbers by the same number. In this case, I divided the two numbers by the same number, which is 2. I used to divide these two numbers. And then I got the equivalent of this ratio. In the same way, if I multiply 16 and 9 by 2, I'm also going to get 32 and 18 back. So to get equivalent ratios, all you need to do is multiply the two numbers by the same number or divide the two numbers by the same number. You will get the equivalent ratio. So let's add some examples. So one example here is ratio 2 to 5. Okay, ratio 2 to 5. Now how can we build the equivalent ratios of this ratio that we have here? We can start with 2, for instance. Multiply the two numbers. You can use 2, so 2 times 2. Multiply this by 2, multiply this by 2. So 2 times 2 gives you 4. You write your symbol. And 5 times 2 gives you 10. So ratio 2 to 5 is the same thing as ratio 4 to 10. That means for every 2 of this item, you have 5 of the other item. For every 2 of this first item, you have 10 of the second item. Now this same 2 to 5, let's build another ratio. The same 2 to 5. This time we are multiplying by 3. Okay, let's see what we have. So 2 times 3 is 6. And 5 times 3 is 15. Okay? Now let's build the next one. We stop there. So 2, 2, 5, right? So times 4, times 4. So you have 8, 2, 20. Now if you look at this number, we just kept on multiplying them with different numbers, As in here we use 2 to multiply the two of them, here we use 3, here we use 4, just like that. So as long as we keep multiplying these two numbers representing this ratio with a particular number at every stage, whatever answer we're going to get is an equivalent of this ratio. It's just the same way it works with fraction. Remember when we tried to build equivalent fractions, we just kept on multiplying the numerator and denominator by the same number, varying the numbers that we use, so whatever answer you get that way, the answer will be an equivalent to the fraction you multiplied. It's the same thing here. So this ratio will keep multiplying with different numbers. Any answer we get is equivalent to the original ratio, this 2 to 5. So all these ratios, 2 to 5, let me list them out. So you have that. Let me write them. So you have this ratio 2 to 5 is the equivalent of 4 to 10. Or let me just write equal to, and it's equal to 6 to 15, and it's equal to 8 to 20. So all these ratios you see represented here, shown here, they are all equivalent ratios. So all you need to get your equivalent ratio is either you multiply the ratio by the same number or you divide them by the same number. For instance, if we divide this number here now by 4, we're going to get 2 to 5 back. Okay? We can quickly try that. So 8 to 20. We divide 8 by 4. It gives us 2. If we divide 20 by 4, it gives us 5. So we are back at ratio 2 to 5. So all these ratios are equivalent ratios. Now we're going to look at proportion now. We're quickly going to look at proportion. So the next part we're going to look at now is proportion. Proportion. Remember I mentioned we first needed to deal with ratio so that we'll be able to understand proportion. What is proportion? It simply is an equation that shows that two ratios are equivalent. Proportion is an equation that shows that two ratios have equal value. They are the same thing. They represent the same thing. They are equal in value. So an example here is, you remember the examples we considered when we built some equivalent ratios. So there we saw that 2 to the power 5, when we multiply 2 by 2 and we multiply 5 by 5, we're going to arrive at ratio 4 to 10. And we said they have the same value. That means for every 2 oranges, you have 5 mangoes. For every 4 oranges, you have 10 mangoes. That's just an example. Okay, so they have the same value, and we saw how that works. The next one here is ratio 1 to 2, and that is the same thing as ratio 2 to 4. For every one of this first item, there are 2 of the other item, and for every 2 of this first item, there are 4 of the second item. So that basically is what proportion is. So we're going to look at some examples and see how this works, because in proportion you will find out that you have 2 sets of numbers. So you will find that one number will be missing from any of the sets or one of the sets, and then you will be asked to use the relationship they have to find that missing number. Because at the end of the day, proportion is showing equivalent ratios. So the knowledge of ratio that you have and equivalent ratio you have is what you use in solving problems involving proportions. So we're going to take some examples so that we have a better understanding of proportion. So an example of proportion is what we have right here on the board. If 2 eggs cost 200 naira, how much will 4 eggs cost? Now, if we're going to write this, we can represent it like this. We will say 2 eggs to 200 naira. Okay? And on the other hand, because it shows that 2 ratios are equivalent, you have that 4 eggs is 2. We don't know. We write x there. But because we know that these two are equivalent ratios, every 2 eggs cost 200 naira. It is going to be exactly what happens when there are 4 eggs. The rate of this money, what this cost, is going to be at the same rate when the eggs increase to 4. So with the knowledge of this first ratio, we are going to determine the value of the money that this egg cost in the second ratio. So every 2 egg costs 200. So how much will 4 eggs cost? That is what this is about. So if you want to write in mathematical way, you can write 2 gives 200, 2 to 200 for 2x. So we know that 2 cost, in 4, you have 2 in 2 places. So if you have 2 in 2 places, that means the first 2 cost 200 and the other 2 cost another 200. Okay, this is just a simplified way of doing it for you. So this is what our x stands for here. Okay, so x, since 4 is 2 in 2 places, that means every 2 costs 200. So this first 2 cost 200, the second 2 in 4 cost 200. So that means the 4 will cost what? 200 plus 200. That's 400. I hope that is, you see that? Let me take it up a bit. So since 4 has two groups of 2 in it, right? And each 2 costs 200. So you have 200 plus the 200. That means 4 will cost what? 400 naira. I'm just introducing the naira now because I didn't want it to confuse us. Okay, so when we talk about proportion, proportion is used to tell us that 2 ratios are equivalent. But in using it in proportion, something is always missing from one of the 2 sets. But the knowledge now that the 2 of them are equivalent will now help you to find whatever it is that is missing. So you see why we needed to go through our ratio first of all before coming to proportion, and especially the equivalent ratio. I'll show you another way we can also get this solved. Now the other way you can solve this proportion problem is, remember we said 2x cost 200 naira, then what will be the cost of 4 eggs? Remember they are proportional. 2x cost 200, 4x cost how much? So you can write it out like this, 2 to 200 for 2x. Okay, and then the next thing you do here is you cross multiply. Okay, you cross multiply. When you cross multiply, what do you have? You will have 4 times 200 is equal to, remember, 2, this crosses like this crosses like this, is equal to 2 times x. Okay, so 4 times 200 is what? 800, and 2 times x is 2x. So what do you do next? What you do to one side, you do to the other. Remember, x is what we are looking for. Okay, in mathematics, whenever you have a letter like this you are looking for, they call it the unknown. The unknown, that is what you want to find out what it is. You don't know it. So whenever you have an unknown in your mathematics problem, always work towards removing it to be alone. Don't let it join with numbers. Keep solving until you are able to make that unknown stand alone. Make it stand alone so that on the other side you can now resolve and find out what it is equal to, a known number. So right now it is still joining with a number. We don't want that. So how do we remove or eliminate these 2 from here? How can we get rid of these 2? We divide both sides by 2. We divide both sides by 2. So 800 divided by 2 is equal to 2x divided by 2, right? So these 2 we cancel 2. I know you in your grade 4 you did cancellation method of division. So 2 cancels 2, that's gone. Now the 2 here also cancels 8, it gives 4, and then you add your 2 0, that's 400, right? I hope that is saying is clear, okay? So you're using whatever you do to one side in mathematics, you always do it to the other side, as long as they are on the either side of an equation sign. Whatever operation you carry out on one side, you must carry it out on the other side. So here we introduce 2, so that why did we introduce 2? We are trying to remove these 2 from x. We are trying to eliminate it so that x can stand alone. It's only when x stands alone that we'll be able to find out what it represents, what is the value of that x. So here, that's why we introduced 2, so that 2 can cancel out the 2 here, and 2 can also divide the other number, which happens to also be an even number. So 2 divides 800, we have 400. So what does that show? That 400 is equal to x. That means our x is 400 naira. And that, sorry, I'm writing 800. Okay? It shows that our x is equal to 400 naira. And when we did the first, when we used the first strategy that we used in the other part, you see it here, this is our 400 naira here. When we used the other strategy, you remember we also got 400 naira. That if 2x costs 200, 4x costs what? 400. So I just showed you the 2 methods. As I always say, you stick with what works for you. If the first one, by splitting 4, remember the first one I just showed you a simple way, that in 4 you have 2 2s. You have 2 and you have 2, right? 2 plus 2 gives you 4. And if they say that this 2 here costs 200 and this other 2 also costs 200, that means the 4 together will cost 200 plus 200, which gives us what? 400. That was how we did our first method, the first strategy we used. This was how we got our answer. But here we said if 2 is 200, 4 is x. We don't know what 4 will cost, right? So we now did cross multiplication. Let me just squeeze it in here. Cross multiply. Cross multiply. Okay, so when you cross multiply, 200 and 4 come together, 2 and x go together. So you now have 4 times 200 is equal to 2 times x. But in maths, we always try as much as possible to make the unknown stand alone. So whatever is standing with that unknown, that number, divide both sides by that number that is with the unknown. That way you will eliminate the number and make unknown to stand alone. So we are able to do that, divided both sides by 2, 2 cancel 2, so x is now alone, so that we'll be able to find out what x is equal to. Then that same 2 divided the other side, which is 800, and it gave us 400. That's how we got our 400. Okay, let's quickly take one more example, and that will be it. Okay, so here is a second example. A recipe needs 4 cups of flour for every 7 cups of milk. How much flour is needed for 21 cups of milk? A recipe needs, let's write out a ratio or equivalent ratios for this problem. Okay, so 4 cups of flour requires 7 cups of milk. So it's the ratio 4 to 7. The ratio of flour to milk is 4 to 7. Then it says how much flour is needed for 21 cups. Remember, flour is written first. So since this is flour, it's written first. Where we're supposed to have the flour we are looking for, we put x, because we are looking for how much flour is needed for 21 cups of milk. So that's how you write out your ratio. Let's go over it again. Recipe needs 4 cups of flour. This is our 4 cups of flour for every 7 cups of milk. This is the 7 cups of milk. Now the question says how much flour is needed. Remember, flour comes first, for 21 cups of milk. So this is how we represent our proportion problem when we have, or you can do it this way, x to 21. It's the same thing. Ratio 4 to 7 is the same as ratio x to 21. You can represent it that way. So, but mind you, we are looking for x. We are looking for x. So if we use the first method that we used earlier, here is what we can do. I'll come back to this method. Okay, here's what we can do. If you look at, we see 4, we see x, we can't figure out anything much. But now let's look at the cups of milk, okay? For every 4 cups, they use x. For every 4 cups of flour, they use 7 cups of milk. So if we know that now milk from 7 has increased to 21, we need to try and figure out the relationship between 7 and 21. If we look at 7 and 21, we know that 21 is a multiple of 7. That is, 7 can divide 21 without any remainder. So how many 7s can we get from 21? 21 will give us 7 plus 7 plus 7. Thus, we can get 3 7s from 21. That means if the first one now has increased to 3 times the normal quantity of milk, is the same thing that is going to happen to 4. Remember, the two are equivalent ratios. They are equivalent what? Ratios. So if 7 now has increased to 3 times its normal quantity, 4 also is going to increase. That means this x now is going to be 4 plus 4 plus 4. That's what it means. Because 21 is 3 times 7. So since 7 has increased to 21, it means 7 is multiplied by 3. The same thing you will do to 4. 4 is also multiplied by that 3. Okay? So if you add 4 plus 4 plus 4, or you simply do 4 times 3, your answer will be 12. 4 times 3 is what? 12. That means for every 21 cups, we're going to have, so let's write our equation again, our ratio again, equivalent ratios. So you will have 4 for every 4 cups, that gives us 7 cups of milk, 12 cups of flour will be needed for 21 cups of milk. So you can use this method, or you use the second method, which we are about to look at again. Okay, so just try to figure out the relationship between, whenever you are given proportion problem, I'll repeat again, you always have something missing from one of the 2 sets of numbers you have. So what you do, the set of numbers that are complete, you use them to figure out the relationship. You use them to figure out how the next set has decreased or how it has increased. For instance, here now the partner of 4 in the equivalent ratio is missing, but the partner of 7 is there. 4 increased to x, we don't know what it is. 7 increased to 21. Now we have 7, we have 21. So we can figure out the relationship there between 7 and 21. We know that 7 times 3 is 21. Or 7 plus 7 plus 7 is 21. So we already know what happened, because whatever happens to one happens to the other. They are equivalent ratios. So for every 4 cups of milk, we have 7 days. For every dash, we have 21. So knowing that 7 has increased 3 times, that means 4 has also increased 3 times to give us x. So 4 times 3 is 12, or 4 plus 4 plus 4 is 12. So that means that for every 21 cups of milk, 12 cups of flour is required. Okay? So this is the flour. This is our milk. Flour, 12 cups, and this is our milk. Okay, so lastly we use the second method. So we have the second method here. Let's see if we're going to arrive at the same answer. So you say these are the equivalent ratios. 4 is to 7 and x is to 21. We're looking for x. We don't know what it is. But since we know that these two ratios are equivalent, the knowledge of this the equivalency of these ratios is going to help us to figure out or find out the value of this x. So like we did in the other case, we are going to do what? Cross multiply. Cross multiply. How did we get this? They told us for how much flour is needed for 21 cups of milk. We don't know. That's why we represent that what we are looking for with x. Remember I said the mass unknown, you represent it with a letter. Okay? So that's why we have that. Now when you cross multiply, 7 comes to s, 4 goes to 21. So we have 7 times x is equal to 4 times 21. Okay? So this is what happens when you cross multiply. So 7 times s gives us 7x is equal to 4 times 21. So you do 4 times 1 is 4 and 4 times 2 is 8. So 7x is 84. But it's only x we are looking for. We're looking for just x. So the only way we can get rid of this 7 from this side so that x will stand alone is to divide both sides by 7. Okay? Divide both sides by 7. Right? So that's the only way we can get rid of this 7 so that x stands alone and we're able to find out what the value is. Right? So you say 7x divided by 7 is equal to 84 divided by 7. Okay? 7x divided by 7 and 84 divided by 7. So 7 cancels 7, 7 cancels 7. So 7 is gone. We are left with only x here, right? We are left with just x equal to, so we divide 84 by 7. We divide 84 by 7. Let's see what we got. So we have x is equal to, 7 goes into 8 just once. So there's a remainder of 1. It comes here. This number becomes 14. The 4 here becomes 14. 7 into 14 we know is 2. Right? So that means x is equal to 12. You see, we arrive at the same answer again. That as 4 cups of flour is required for 7 cups of milk, $12 cups of flour will be required for 21 cups of milk, which is exactly the answer we got when we used the first method. Okay, so whichever method works well for you, just stick with it. That's what it's all about. Finding what works for you, finding what is convenient for you. Okay? So this is where we're going to call it a day for today. So we thank you for being here with us and we hope to see you again next week. Okay, till then, stay blessed and stay safe.